Gas laws, lecture number 6, STP. So for gas laws, if we're going to say something's at STP, we call this standard temperature and pressure. So the standard temperature, so our temperature is going to be 0 degrees Celsius, and our pressure is going to be 1 atmosphere. Okay, these are always the conditions under STP. So let's say that we want to solve for something at STP. So to get this molar volume relationship, okay, we know that for an ideal gas law, we've got a P, a V, an N, an R, and a T. Well, my temperature is 0 degrees Celsius, so it's going to be 273.15 Kelvin. Okay, my R, I know my gas constant. Okay, when something's at STP, we're going to assume that the number of moles that we use in this relationship is going to be related to the periodic table. We know everything at the periodic table is to 1 mole. So we're going to say that our amount of our gas is going to be to 1 mole. Okay, our pressure is 1 atmosphere. Okay, and we want to know what's the volume. Okay, we're going to solve for the molar volume. Okay, so my pressure is 1 atmosphere times my volume equals my number of moles, which is 1.00, times my gas constant, times my temperature. Okay, so now to solve for volume, we divide by our atmosphere. Okay, we get a volume of 22.41 liters. Okay, we call this the molar volume. So any gas at 1 mole will always occupy a volume of 22.41 liters. Okay, to give you a visual representation of this, this is 22.41 liters. So this is the amount of space that a gas will occupy under these conditions. So let's say that we have a problem and we want to figure out the density of a gas at STP. So let's say we want to know what is the density of chlorine gas at STP. Okay, keyword here is at STP. Whenever you see STP, we're going to use our molar volume, which is going to be 22.41 liters is to 1 mole of a substance. Okay, so here we've got chlorine, which chlorine gas is a Brinkelhoff, so it's one of the diatomics. So we're going to see chlorine written as Cl2. Okay, now to solve for density, we know that the equation for density is D equals M over V. Okay, so remember, we're always doing 1 mole of a substance. Well, we know that it's at STP, so therefore my volume is going to be 22.41 liters. Okay, now to just figure out my mass. Okay, well, it's to 1 mole. Cl2 is 1 mole of Cl2. We go to the periodic table and get the mass of chlorine, but there's 2 of them, so we have to multiply it by 2. The mass of that is 70.9 grams. Okay, so now I've got mass, I've got volume. Divide the 2 to get the density, and we get that the density of chlorine gas at STP is 3.16 grams per liter. Okay, so STP is very useful for when we're holding something at these conditions. It needs to be at 0 degrees Celsius and 1 atmosphere. Okay, if you ever get lost as to what that number is, remember, it's derived from the ideal gas law. That's how we got this. So just plug in your conditions. You've got 1 mole, you've got 1 atmosphere, and you've got 0 degrees Celsius.